let me introduce myself. So I'm Vladimir Zaporsky. I'm working at Linaro for the last 3 years. I'm Linux kernel engineer. Was involved in my career in the development of multimedia device drivers for automotive and handheld devices and so on. So here I continue to work with the Linux kernel and working as with the customer support. And that's a very difficult topic for every customer who uses Qualcomm powered boards but don't want to run a downstream BSP. So basically almost all components of Qualcomm BSP can be replaced right now, but there are a few of them, and camera is one of them, which is not easily replaceable. There is a CAMSS, so it's not long ago, it appeared in the Linux kernel, in the vanilla Linux kernel, but still its support is very incomplete, and most probably I would say that it will never be completed without active Qualcomm support. The good news that it might get good enough at some point. So, and practically even today it is usable. There are a lot of presentations, for instance, last year on the Linaro Connect with the examples how to use it, and there are more and more Qualcomm SoCs and boards get support in CAMSS. The overall IP is extremely complicated. All the specs are closed. There are very limited amount of public information. I do not have access to any of the Qualcomm specs, so mainly everything which I can present you is a summary of publicly available information, but anyway, it's even that is pretty large volume. Okay, so the plan for today's presentation is a brief overview of hardware components and a brief overview of software components, downstream and upstream. So let's start from the acronyms terms. Even those are not public. So, but fortunately, there are ways to get information about it. Since even for Qualcomm BSP, they have to share some information, user interfaces to the camera driver and so on, and some bits of documentation where you can get some of the acronyms deciphered. So what do we have? All of those could be considered as a part of camera subsystem. However, camera clock controller is probably separate one, so it's a part of the clock controllers. The clock controllers support is open, so basically it's pretty straightforward task to forward port it from downstream to upstream, and that's done for practically all SoCs, but CAMSS, which uses CAMSS, that's a different story. So all of these things are part of CAMSS. First comes CCI. It's also a part of CAMSS, but it is defined in the MIPI spec, CSI2 spec. It's basically I2C compatible bus. CSI also, the serial interface to communicate with sensors also comes from the MIPI spec. Next, CSID, it's camera serial interface decoder, IFE, VFE, image video front end, test pattern generators, sensor front end, and so on and so forth. So basically, it's even the thesaurus can be, I don't know, very large. I won't spend more time on it. So these things are present in the upstream as well, at least partially, not all of them. ICP is missing part, but ISP, image sensor processor, it contains of video front end, which provides a number of output data formats. Mainly we use, and this is basically used by current users of any CAMSS and upstream kernel, is raw dump interface. It provides a raw pixel interface in bare format, because the next IP block in CAMSS is ICP, image control processor, which has pre-formatting IP and post-formatting IP, or post-processing IP. This is not in the upstream, so, and that's probably would be very good idea to get it into the upstream. After that, I believe the CAMSS will be usable for the 95% of use cases for everyone. At this point, no one actually is interested in, I mean, among the customers to whom I communicated, no one is actually interested in having only this part. There are some workarounds, for instance, doing deburring in software in user space, or using deburring in the GPU, but no one does it. No one does it, but of course Qualcomm does not want to put this ICP deburring to upstream. If they do this, they will lose the control of what to deliver to the customers. So that's the reason. Here, yes. So here we do have CAMSS APIs. So the ones to which we know at least something, which are present in the upstream, and it means that we know more information, we can control, we can make modifications to the vanilla kernel, make updates, see some Qualcomm engineers submitting new CAMSS support to new platforms, for instance. Those three components are present, and only this. CSI-Fi is a component to communicate with the sensors, and CCI for controlling, I2C bus, CSI-Fi for communicating and getting data from the sensors. CPass, oh yes, CPass is not present. It's actually not even security-related module. It's a module to hide the communication with the sensors for Qualcomm BSP and Qualcomm camera. So in upstream, we do not need it, and actually the CAMSS works pretty well. So it's like camera, peripheral, and system, and it works pretty well without it. So, but it might be used for interconnect voting and so on. So it has some applications as well. That's what we get from the downstream kernel driver. And ISP contains of two parts: CSID, the decoded images, and processing, raw processing to formats. All of that ISP is also covered by MIPI spec. So the video channels, the virtual channels, and data types, and all of that, which is parts of ISP, basically someone who is familiar with the MIPI spec can get. This part is not covered by MIPI spec. It is Qualcomm closed spec. So let's take a look about this. So probably this is already done. We have VFE here containing of top parts, CSID and VFE bus. SFE is sensor. Those are CSID decoder. From the decoder data comes to front ends. This is image or video front end, then sensor front end, thin front end. Those two are missing, but we have to add this to the device tree, since that's a description of the hardware which we have. those are used to get more information, for instance, statistical information from the sensor and get more control of the sensor. That's also what customers want to have, and this is not present in the upstream. Probably someone will add this support to the upstream, so who knows? Let's see. Everyone, so again, so as I started, I can repeat, that's a very important thing. Customers have a choice to use the downstream kernel, Qualcomm BSP, or upstream kernel. Someone selects to use downstream kernel or Qualcomm BSP vendor BSP. That's fine. Not all of them anyway wants to use downstream software. Someone finds benefits of using upstream software. They do not have any other choice but using this limited version of the CAMSS, or contact someone who can extend or do more than it provides in the upstream. And if, let's say, the community as a whole wants to benefit, then yes, somebody has to add these blocks. As I said, so my understanding that it's not in the desire of Qualcomm to add these blocks. So that should be done by somebody else. That's a good question. Actually, all the work which I did and which I present here, I did without reverse engineering. But reverse engineering is also possible, why not? But it's at least something. For instance, 8450 support to the kernel, which was recently added and done by me, it was done absolutely without reverse engineering. It was open source kernel driver portion plus, since we do have, yes, this driver, which I will tell about it later. So thank you for your questions, but I can return to it a bit later. But to complete with it, there is a publicly available camera driver. It's possible to build it. It's possible to run it. It's modified version. There are a few number of tracing abilities. It's possible to trace CAMSS. It's possible to get, basically, it's possible to get traces. It's not reverse engineering. That's what I did. Power management. Even power management, that's an important thing, but I will briefly describe it. Yeah, so two parts, sensors and CAMSS. About sensors, we have master clock. That's controlled by pin controller, sensor-specific regulators and controls. What is I found very interesting, and I haven't seen it before, and actually there is no support in the upstream even today, that CCI interface, I2C interface on most of the Qualcomm boards connected to the connection to the sensors, they are pulled up by regulators. So there is no such thing as I2C bus pull up by regulator in the upstream kernel. So it's not a difficult technical task, so someone wants to add it, for instance. But most of the boards, they do this way. CSI voltage regulators, that's another story. So the most control of CAMSS components, they are done by power domains provided by CAMSS, GDC power domains. There is a number of them, clocks and interconnects. But CSI PHY, it requires the external voltage regulators, a set of them, and they are very, again, unusual. So commonly you cannot power just one CSI PHY. There is one regulator for a number of CSI PHYs, at least on modern SOCs. Yeah, okay, so there is still some discussion about how to describe it properly in the hardware description in device trees. That's very brief, again, view of how the data flows. So we do have camera, it goes to CSI-FI, CSID, VFE. All this level, that's the level of CAMSS, and goes to user space over standard video for Linux 2 interfaces, and you can use user buffers and so on. So, but the current support, that's upstream. Downstream is extremely complicated. Extremely complicated. So that's the upstream. That's all what we do have in the upstream. To user space, we get the raw data images, which has to be processed further. So basically, you cannot even display it. There are no standard libraries, or at least maybe there are, but again, so you have to configure it and deal with that with the libraries which do the debayering of the images. And there is no any feedbacks to sensors. So everyone wants, for instance, I don't know, there are pretty many other components which are missing here on this picture, but which are present in the downstream and on the ISP itself. So I just list them: phase detection, JPEG processing, image stabilization, flash control, focus depth, autofocus, noise reduction, white balance control, and so on and so forth. So there are feedback loops to camera, so sometimes you have to control to adjust some camera controls based on the statistics again, which is collected by some of the ISP components which are not present in the upstream, and it would be beneficial to get them. But that's what we have. Yep, about ISP, there was a good presentation last year, I think, that which described all the ISP. That's the parts which we have in the, again, in the upstream. CSID, so CSI-FI somewhere else. Outside of that, there is also user space. That's what we do have in the upstream. So CSID are connected to IFE, like on the previous slide is shown. Sensor front end and thin front end, they do not have support in the upstream. Sensor front end gets or collects some statistics, and probably it makes sense to add it to the user space from my, to the vanilla kernel from my perspective, because it allows to close one open task for customers. Everyone wants to get better control of the sensors. But again, so we can live without it. So if we are satisfied with the quality which we get without adjusting the sensor, so predefined sensor configuration in the upstream kernel, that's fine. And test pattern generator. About a brief overview of the downstream code. So the camera kernel, that's the device driver from Android BSP, which is given or provided for multiple versions of BSP. It can be recompiled along with the BSP kernel, downstream kernel. And it also requires MMRM driver. So those two downstream drivers, along with the downstream kernel, if you do compile, you can get the working camera from the Linux kernel point of view. So it's independent. These are kernel parts. And there are user space components, so CAMSS library provided by Qualcomm. And custom applications can use this CAMSS library. The CAMSS library has its also tracing information, so you can enable and get some information at least with it, from it, which sometimes helps. This kernel driver, as usual, as almost every kernel drivers which communicate with the user space, they provide the UI API. You can get all these symbols, for instance, or whatever. So some features which are supported in this or that version of ISP for that particular platform from this camera driver user interface. UIPI, yes, helps to get more information about CAMSS. this is also a very good source of information because it evolves with various SOCs. So basically you can see what is added, what is new in the new version of SOC, what is supported, on, what is removed. Going back about this camera kernel driver, it gets less and less and less in size with every new release. So why? Most of its information goes to user space. Most of this functionality goes to user space. Still, there are something which can be obtained from this driver, from the sources of this driver. On the other side, it means that if you take a very old or pretty old version of this driver, a pretty old version of SOC and BSP, you may get even more information about CAMSS. So probably you may get better support in the upstream if you have an idea of porting ISP support of some Qualcomm SoC to upstream. Probably it makes sense to start from the old SoCs. You may get immediately more information publicly available. The interfaces, IOCTL is mostly, there are some IOCTLs, so according to this UAPI, but not so much of them. There are some video for Linux interfaces, but most of the controls, they are done by mmap, so it's not very trivial to trace, again, without reverse engineering, but again, so it's possible. So since if there is an option to recompile all your components, including the kernel itself, so there are pretty many options how to deal with it. Yeah, so that was about downstream. It's not very interesting. So about the vanilla Linux kernel, we do have these components CAMSS. They are located over here. CCI is a single driver. There are two versions of it. So old versions, they provided one interface per controller. New versions, they provide two interfaces per controller, and CAMSS is found over here. It has these components, CSI-FI and ISP. Test pattern generator is not supported on all supported CAMSS versions, so it evolves also pretty rapidly, so it moves between various versions of CAMSS. What is also important to say that actually Qualcomm releases CAMSS ISP. The major changes to IP are done every second year, and mean that if you find some version of ISP already supported, it means that you can most probably very easily get supported a version which is close to it. So let's say a year before it, or a year before it. So the same generation. It gives an option, yes, to get more and more SoCs supported. At the moment, there are not so many of them. CSI-FI is actively reworked, and I hope it will be reworked at least. Those things working pretty well. ISP-IF is the interface on old versions of SoCs. So on modern versions, it is not present. So let's see what's around the kernel. Basically, there are two things, the hardware and the user space. So I just take the open source Vision Mezzanine for RB5. That's how it works right at the moment. So you have this description. Supplies for CSI-FI, data lanes, and remote endpoint to the sensor. So pretty straightforward. It shouldn't be very difficult to add when you support. Talking about, for instance, this particular RB5 board, we can find that RB5 Vision Mezzanine, we can find that there is a second sensor on it, which is not yet supported in the upstream for whatever reason, so no one cares probably. The driver is present in the upstream, so I mean the sensor driver itself is present in the upstream, so but no one added it over here. So again, another technical task for someone. That's the proposed rework of CSI-FI. It should be a different device. FIs will be similar to the layout is similar to the ones which are done with MDSS. So we should have a list of supported FIs enumerated. So here it's sufficient to have only one FI enabled, for instance, right? If we to have only one sensor, it gets its own clocks and interrupts. And the previous thing, so which was a part of CAMSS, becomes CSI-5. Why is it important? Because there is to make an abstraction of CSI-5, for instance, there is, again, a feature of, a very useful and nice feature of Qualcomm CSI-5 IP, that you can put two sensors to it. So it is called combo mode feature, and it is not possible to implement it without a combinatorial explosion at the current scheme which we have at the moment in the upstream. So it has to be reworked, and customers want it. And user space. Again, that's an example for RB5. You can get the media device, so all these things, a part of the sensor itself, are CAMSS. The sensor, you configure and link them, and start capturing. So it's pretty simple, nothing complicated. The only thing probably which is a bit different, that you have to make the controls of three sub-components of CAMSS independently here. That's the current list of supported SoCs and boards. Those are supported, those are under review, still not, but you can find them on the mailing lists. What is the most important here, to my understanding, is that it's almost 50% to 50% reference boards or development boards and consumer devices. So there are a pretty significant effort done by hobbyists or customers or whoever, but not Qualcomm or not paid by Qualcomm, to support the CAMSS on consumer devices like phones or laptops. And that's about the next steps, which at least I see as a developer of CAMSS. So complete the work of CSI-FI, split to its own driver and extend the interfaces, and optimally get the backward compatibility between the new scheme and all the currently supported versions of CSI-FI in the upstream. Add more features to CSI-FI. It's not a very complicated IP, and it's already a part of CAMSS. For instance, this combo mode, so that we can put two sensors to a single CSI2 bus. TPG, so there is a work TPG is partially supported in CAMSS. It was reworked, it was moved from CSID to CSI-FI-like IP recently. And most probably it will become a standalone component, and it will require a standalone driver. So raw data output is sufficient, but not something which is really wanted by anybody. But sufficient for testing, for instance. You can get images from a sensor. Probably it's not good enough for market. Very important to get metadata and statistics. So that will require to get support of more front ends like SFE and TFE. The code itself is very low quality code, so reworks, general reworks, cleanups, and tons of bug fixes are known. There are even still some issues with the power management scheme inside the driver. So basically even power scheme like PM runtime and so on is not very good in the drivers still. Sometimes, for instance, I provided the versions of RB5. Even if you take the RB5, sometimes you cannot get the sensor connected to CAMSS like in 1 in 10 booths. And yeah, more support for CAMSS on more boards. That's it. Thank you.